So hi everyone, welcome to my YouTube channel. In this video I am going to explain you how to find out the ballastic constant with the help of ballastic galvanometer. So here is the ballastic galvanometer. So the apparatus required for this experiment are the DC power supply, rheostat and the scale which is put on this stand, and here is the voltmeter. Along with this experimental kit they have to provide condenser, so in place of that I am just making the connections using this box so that you should understand how exactly this experiment has to be made. And here are the plug keys, and you should require one more component here, charging and discharging key. So instead of that I am here made connection with the help of plug key to explain this experiment. So ballastic galvanometer consists of a mirror. When light falls on that mirror, we are due to a electric and magnetic field effect that is going to deflect. So the deflection in the mirror we can observe on the scale. So we should require dark room to perform this experiment. When the light from the mirror falls on the scale, we should measure the deflection, and the distance between the ballastic galvanometer and the scale must be 1 meter. So I am going to explain you the connections here. The ballastic I have made according to the circuit diagram the connections. Ballastic galvanometer which consists of positive and negative terminal. So from those two terminals we are going to connect 4 wires. So one terminal is connected to 2 wires and another with 2 wires. Those 2 wires goes to the remaining components of the circuit. So for example, if we take the positive terminal, here we have to connect this to the ballastic galvanometer parallel to the key using 2 terminals. So from positive and negative, 2 wires are connected to this key, and the another wire goes to the condenser, that is to set the capacitance value, and this condenser wire goes to the another key here. So another wire of the ballastic galvanometer goes to the another terminal of the key. So all this ballastic galvanometer, this key and the condenser and voltmeter are connected in parallel. I will show you the circuit diagram. So next another terminal of the condenser goes to the positive terminal of voltmeter, and negative terminal of the voltmeter goes to the key, and there is a common connection between the key that is connected to this condenser and the ballastic galvanometer. Here I have connected, and then another common terminal of this voltmeter and the key goes to the head of the rheostat. So the lower terminals of the rheostat, one wire is connected to the DC power supply, one lower terminal of the rheostat, and another lower terminal of the rheostat connected to the plug key, and another terminal of the plug key connected to the DC power supply. So this is the connection for the to find out ballastic constant of the ballastic galvanometer. So I am going to explain you how to measure the deflection of the mirror on the scale. To start this experiment, we should switch on the power supply, and before that we should set the condenser capacitance value, and we should set the once we switch on the power supply, we are going to observe deflection in the voltmeter. Note down how much is the voltage. Then so here this scale, as we know, consists of the length of 25 centimeter, and here the light source is there which falls on the mirror. Here the connections has been given. We can connect the plug directly here. So here one more plug goes to the power supply here. The voltage that we want to set in the voltmeter, we should adjust with the help of rheostat. So we should keep the voltage constant, and actually, as I said, instead of the charging and discharging key, I am using those plug keys. Once you press the charging or discharging key, then the deflection, whatever the reflection of light on the scale, you will observe the deflection of that light on the scale. When you press the charging key, the light is going to deflect from left to right. Once you leave the charging key, or if you discharge, then this suddenly that light spot stops on the scale. It will not move. So you have to take the theta 1, whatever the deflection you are observing, change in angle in terms of this change in the deflection in terms of the scale 0 to 25 centimeter left and right. Usually the voltage you need to set in such a way with the help of rheostat that the deflection you must observe between 15 centimeter left or right. How you will increase voltage or the capacitance value, then the range of the deflection of light may vary. So you should not set the voltage such that the reflection of light on the scale should not go beyond 25 centimeter. So whatever the light is going to reflect, or we call that as a first throw or second throw, like that. So first throw, if it is at 15 centimeter on the scale, then the second throw, when you charge or discharge, so this will move from left to right. So second throw will also be at around 15 centimeter. Then third throw, fourth throw, 6th, 7th, 8th, 9th, 10th and 11th. So 11th will come where exactly the first throw is there, and then that is less than the assigned value, that is 15 centimeter. With the help of formula, you can calculate using the value of theta 1 and theta 11 ballastic constant. So the aim of the experiment is to determine the ballastic constant of a moving coil ballastic galvanometer with a standard condenser of a known capacitance. So apparatus used already I have shown you. Formula used to calculate the ballastic constant of a moving coil ballastic galvanometer is given here. K is equal to C into V divided by Q into 1 plus lambda by 2. So capital C stands for capacitance of the condenser, V voltage of the shell used for charging the condenser, Q first observation through when the condenser is discharged through the galvanometer. So lambda is the logarithmic decrement is given by this formula 2.303 divided by 10 into log 10 of Q1 by Q2. So the observation for this experiment are we should note down the capacitance of the condenser and distance between the ballastic galvanometer mirror and the scale point. So here are the values that we have noted in the tabular column. So first you can take the 3 trials. Applied voltage you should note down for each time. So here we have taken 0.4 each time. You should note down the applied voltage 0.4, 0.5, 0.8, and the deflection of the spot of light corresponding to the galvanometer you should note down on the scale. So the that is about Q1 about 8.5 for the applied voltage of 0.4 and the Q2 value that is 0.2. So Q1 and Q2 values you should note down here for applied voltages. Then lambda is the logarithmic decrement you can calculate with the help of value of voltage Q1, Q2 and the capacity with the help of this formula. Here I have calculated lambda 1 for the first applied voltage 0.4 and the Q1, Q2 value is 8.5 divided by 0.2 Q2. So then like that you should calculate the lambda 2 and lambda 3, and after that you should take the average of these 3 values. You can write down in the last column mean value of logarithmic decrement. So we have got about 0.35 the mean value of lambda. So then ballastic constant you can calculate once you calculate lambda. So put the value of capacitance of the condenser, that is about 10 to the power minus 6 micro, that is farad, and the voltage applied, first voltage 0.4, Q1 value 8.5 and the lambda 0.35. You can calculate the K1 for the applied voltage of 0.4, applied voltage of 0.5, 0.8 you can calculate, and take the average or the mean value of the ballastic galvanometer. Once you add and divide it by 3 you will get the average. The average value or the ballastic constant we found about 3.86 into 10 to the power minus 8 coulombs per centimeter. So at the end you can write the result. The ballastic constant K of the ballastic galvanometer is you can write down in the result. So thank you for watching. I hope this experiment is helpful. So please do subscribe my channel. Thank you.